Alright, Mr. Gatekeeper here. I have a Davemade straight 8 here, and I'm probably going to go ahead and guess this is not an original Dave. I don't believe it is.
Hey Jason, thanks for joining me.
Yeah, this right here, this is painted.
Let's get to the 1991.
It ain't the decal.
What is that?
The 1991 agreement has to do with an arrangement made between the Cabal and what is now referred to as the Mars Germans, since they moved pretty much the bulk of their civilization out of Antarctica to Mars.
And so you got this right here. You can take a look at the ground bolt. The ground bolt is directly to the case, okay?
The Cabal was...
There is no strap going from that ground bolt to the board. So these transistors have to get their ground through this path right here. Think about it. This bolt, I don't know where the nut is, and it's not stainless, I can tell, but you know, that's beside the fact. But this bolt right here is on the case, okay? And this is an anodized case. It's a good ground. All right, but these transistors are soldered to the copper board. So these transistors have to pull it from this case. Now let's see where the board is connected to the case. Right here at this SO239. This SO239 is not even soldered to the board.
The Germans did have to find a new tenant.
It's almost like somebody just absolutely forgot to solder it, which I do not understand that. That may be the first time I've ever seen that before. Somebody actually forgot to solder it, because you can tell there is no solder spot. So that's been that way since the guy bought this box, or whoever bought this box. So the transistors are going to get their ground from... Sorry about that, the battery died in this thing. So back to what I was saying. So since that SO239 is not clipped to the board, so we got a ground path of that SO239 right there, which is connecting the case to the copper board. And these nuts, not these solder points, okay, because these nuts is what actually connects the case to the ground, okay. And if you'll notice, these nuts are not stainless. Okay, so we got 3 nuts on, let's see, 4 nuts on each side. I would say that is not a good ground path for these transistors. I mean, I'm not going to sit here and say it's not going to work and it wouldn't work efficient, but I would not feel worthy of trusting that. You know, it's not that hard just to go ahead and put yourself a piece of braid from there to the board, which is what we'll definitely be doing. I've had to do this to a few Davemades, and I do not believe they're original Davemades. I don't think the original Dave would have done that. Next thing, I'm just kind of going here, just kind of looking around. Somebody has been in here and tried and did a B+ mod, and you can tell their iron was not hot enough. Because if you take a look, I'm trying to do the zoom here. There we go. Look at this. Whoop, just pulled it off. And it does not appear that they were using some good solder either. If I had to take a guess, I would say maybe some acid core solder or something. Not a good solder to be using for this. You need to use a flux type solder. These connections are okay. And we got one over here that's jumped up. This was actually jumped up upon coming here. And the board looks, you can just tell someone didn't have a hot enough iron. So we're going to remove all this and put our own B+ on there. Okay. And we're going to take these, take the combiner, splitter. We're going to take them off, put some 3 ports down, retune the input and output network. Got a little bit of old question mark, but that's not a question mark. That's a U. That's what I'm saying. This is not an original Dave. I just don't see it. I don't see it. I'm gonna put some stands on the bottom of these transformers too. They're about close to touching the board. I just don't like that when I see that. That's why whenever I build my boxes, I just grew a habit to putting stands on the bottom of the transformers. It's just something I like to do. You just know there will never be an issue with doing that. And the reason why those are so close to touching almost is because these pill strips are not glued down, which I'm not against that. Don't get me wrong, I'm not against that. But that doesn't give as strong of support for the transformers when they're soldered down as if they were attached to the board. You know, I completely understand that's a lot of people's style. I will admit, I'm a guy that still glues his down. I will admit though that in the last 2-3 years, I just put enough glue just for the strip to hold for me so I can solder my stuff. Everybody's got their own ways of doing it, and you know, to each his own. Some ways are probably faster than others, etc., etc., etc. So we're going to have to we're probably going to change all the input. We're probably going to change the output coaxes for sure. I'm going to remove one of them and measure it, and but I don't think that that's going to work out. We're going to have to redo that because all this coax needs to be the exact length. So I'm going to remove one of these and just measure it and see. And I'm going to have to figure out where I'm going to put the next 4-pill section, which it doesn't matter where I put it. I think I'm probably going to put it on this side right here. So I'm going to need to drill my holes, get some pill strips down, get some 5/8 core transformers. I'm going to keep it as original to Davemade as I possibly can. So I got a little bit of work cut out for me, so I need to get started. Just wanted to kind of go through and show all the transistors are 3Cs except 5H right here, which I can tell has been put down not long ago because it just isn't soldered as good as the others are, if you can see what I'm saying here. So we'll get down here and clean up everything. And it looks like that 10 ohm scorched or skeeched just a little bit. If you can see, it's a little discoloration. I didn't replace it. So I'll check the inductance of these, but if I had 2 more of them, I could use them. But I don't got 2 more. I don't got any of these green cores right here. Plus, that's another thing. When you want to do stuff like this, you don't just grab a core because it looks pretty. You want to look at the inductance of that core, okay? Because you're trying to get a certain amount of inductance for the lowest frequency that you're going to be using, which, as we know with this, is you know what it is. You know, I would say maybe I use a lot to calculate around 25 megahertz. If it was a broadbanded box, you'd go down to 1.5, 2 megahertz, somewhere around there, if you want to hit the 160 band. But these are narrow banded amplifiers, so I always try to make mine up around 20 microhenries just to be safe. 10 bare minimum's fine, but we're dealing with a little bit of power here. I like to go up around 20 to 30 if I can. But anyway, let's get in here and get started. I see the fans too. There's a variable right here for the fans. I'm going to hook the power up to see how that's working. We've got both fans being shared by one regulator here, which is a high dollar regulator. You know, that's fine. But this is now going to be a 12 pill. I may end up changing these fans out to 2 faster fans. And I wish I had a lot of extra time. I'd throw you a proper. What are you doing? You just jump up here like you own the place. Could put you a proper voltage variable fan controller. But you can use motor controllers for these bad boys, because they are motors. I've got some that got up to 10 amps, man. You can put on some strong fans. Heck, we'll see. I may just take this off and mount one in there for you and put some big bad boy fans in there for you. But I got to get started, man, because I got some other projects I got to get done with this week. We're on Tuesday now, Tuesday night. Well, Wednesday morning. We'll be back. Alright, Mr. Sidewinder out of California. We got the sides off the Davemade. This is not an original Davemade. This is one of the newer ones. And I actually just got off the phone with you, bud. But like I said, this one has 4 10-gauge wires. Okay. Now that right there will roll. That right there will roll with an 8 pill. You know, that right there will roll. That will do. That will do. You know, you can pretty much say this is right here is close to equaling it to 8 gauges, an 8 gauge per 10. You could say that, and that's fine. You know, that I could roll with that. A lot of people will say, like, you know, 1 10-gauge per 2 transistor section. Well, there's your 1 2 gauge per 2 transistor section. But the problem is we're putting another 4 pill section down, so I'm going to have to go ahead and disconnect this from the back, unsolder these right here, and what I'm going to do is I'm going to drop 4 8-gauge wires in. I thought about trying to do a 5th one, but this 8-gauge that I use is quite thick. It's quite thick, so at that point you're going to be good, because you're going to have a little bit more than 1 8-gauge per section, since you'll have 4 8-gauge wires that are pretty dang thick, man. These new concept wires, I absolutely love them. And I'm just going to go ahead and roll with the studs right here. Now, I've seen the original Dave use these studs too, so, but I'm just going to go ahead and roll with these studs the way they got them here, and build your splitter and combiner to them. That's perfectly fine. They're isolated. They're up in the air, so that right there will work. So I'll just build the splitter and combiner around there. And this is all the parts I've had to take out of it so far. Now these were some pretty good stiff 1000-volt 75 picofarad caps, which is pretty good. That's pretty good. I like that. I wish I had some of these laying around. I could just put 2 more in there on the next one, but we're going to use some good $5 orange dip caps, probably, I think is what I'm going to use. And so we're just going to keep this thing Class C, like you said. You want me to throw an SSB delay. And see, let me tell you right here. This is something that you asked me about. You're like, well, running Class C on sideband, is it bad for my transistors? Now here's the only way I can answer this. I can only answer this from experience, because now this was due to me not knowing too much when I first started off. But I ran a Class C amplifier, okay, on sideband, hardcore sideband, for like 3 to 4 years. I didn't know it was Class C. I thought it was biased. But you know, this was back when I first started. I didn't know any better. And that amplifier still works today. I actually went in there and painted the case, and my buddy Eric Sharp's got it. So it's still working today. And I have talked to many people that's ran Class C boxes on sideband. I mean, the transistors are already cutting on and off, cutting on, off, cutting on, off. The only difference is when you put that bias to it, they don't cut all the way off like they do on a Class C. On a Class C, they cut all the way off. I guess if you were looking at that with a logical mind, you would think that since the transistors had to cut all the way off and all the way on, all the way on, off and all the way on, that it's more damage to them like that without a carrier. But when you actually get down and look at it, I have never found any refutable evidence telling me that it's bad to do that. Now, if you're going to be a hardcore sideband operator, where you're going to be hardcore with it, you know, up above channel 40, up on 10 meters, 12 meters, whatever, it needs to be biased. But like we talked about, you said that you have another amp that you like to use on biasing, that you like to use on sideband when you're on sideband, and you got a good beam up, some good gain, and you know, you do what you talk to wherever you want to talk with that, but you wanted me to add the sideband delay just in case you ever did decide. So there's nothing wrong with that. I don't see nothing wrong with that. Now, until somebody comes through and actually describes and shows me technically how that is not good for the transistors, I'll change it. Because, hey, I'm a reproof type of guy, man. I'm learning in this thing. But as so far, man, people have ran Class C boxes on sideband for years. And you know, and I've only heard a very few people ever say that I don't think that's good or that's not good. Only a very few. But experience means more to me than someone telling me, just because I've done it and it's never caused an issue with me. I've run more than one on like that. I actually, when I first heard that, just for the fun of it, I ran a little 4-pill on sideband a good bit, just for the fun of it. But you know, who knows, man? Who knows? I just got to go off experience. All right, let's get in this thing. Let me quit talking, man. I got to get this thing done for you, big brother. So we're going to try to wall off these right here in the back the best that I can. I'm going to have to remove this. I'm going to check these connectors out. If they're still good and I'm happy with them, we'll keep them. If not, we'll throw you some other connectors on there. We're going to get rid of that bolt right there. Put you a stainless bolt on there so you'll never have to worry about that corroding. I'm a big fan of stainless, man, on these boxes, because you don't never know where they're going. Up north, near the ocean, you don't know. It's just best to go ahead and spend that little extra cash and go with stainless. And we will do your Snake Eye mod too. Hey, we'll be back. The GK said that. I'm gone, but I will be back. Alright, brother, we're moving along a little bit further here. I went ahead and had a little idea. Oh, got some solid copper sheets here I've had for a little while and never gotten around to using. So I thought I'd kill two birds with one stone with wanting to block the little bit of the air, the air ports in the back, allowing the air to escape out the back without going through the heat sink first. I thought I'd kind of kill two birds with one stone here. Use this side to block the top of the air ports, and also to use this as your ground, which is heavily overkill. But when it comes to grounding, there's no such thing as too much, as they say. So we're going to do that on that part and on this part. So I'm going to have to wait until I get the sides on so the board is elevated properly before I actually drill the holes. The 3/8 hole in the back of this for the bolt. Get all your stainless hardware right here that we're going to be using. This is what came off of it. Zinc plated. It is corroded. That's what zinc plated does. So we got you some stainless now that we're going to be throwing on there for you. So I'm going to get all that up, get the sides on it, and then go ahead and drill the hole. I probably won't have to put two mounting holes on this side, on this one right here, to mount this against the back of the box, because the bolt will be pretty much mounting it. But on this one right here I will. I already drilled some holes already, and I elevated it and drilled the holes already. So, and then basically I'm just going to drill straight through that copper that your SO239 is going to go through, and you won't have to have these, because now you'll have one big grounding bar right there. And I'll get down here when I get finished. I'm gonna get down here with a little bit hotter of an iron because once I got this copper on copper, so the thing about copper is it soaks up heat so dramatically. So you really got to be coming with some heat when you're soldering copper. A great deal of copper like that to copper. So I'm gonna get down here with my big boy gun. I got 250 water. I got 250 water, and I think I got 150 water. One of them will do the trick. I'll probably start off with 150 water. But anyway, went ahead and got your holes drilled for the transistors, and got them tapped. I went ahead and tapped them. So what I'm gonna do now is, these are your transistors that came out of your Texas Star. I already cleaned them up. Got the leads, you know, straightened out and all that good stuff. Cleaned all the flux off of them. Got them looking nice for you. So I'm gonna go ahead and get them mounted, and then I'm hitting the sag, man. I'm gonna get on this tomorrow. This has turned out taking a little bit longer than I anticipated, but just about every box does. And I had to remove this to get to the bolt, so we'll get that. I'm gonna have to retune the network, so what I'm probably gonna do is use a tuner. I'll use a tuner to tune the output, then I will get this mic'd in and put it back on there. I like the way the guy had actually done that. He's got a little extra copper in there, so I can just kind of heat that up and adjust it where I need to. Pretty cool. Pretty cool idea, and it won't be moving. You ain't got to worry about gluing it that way either, or putting tape on it, because it will not move. And I've cleaned the board up a little bit for you and everything too. It's quite a bit dusty. Alright, man, we'll be back. Alrighty. Alright, got the 4-pill section down. Got all the input output loading caps installed there. Got the $5 orange dip 150s there, thanks to Mr. Tony up there at ICA. And so next I am going to probably go ahead and get the splitter and combiner made and get them mounted up there on the stands. Okay, after that I'm probably going to go ahead and get all the coax runs done, all measured up. Let's see if we got 1, 2, 3, 4, 5, 6 total that we need. 3 on the inputs, 3 on the outputs. And we'll have to make a new input coil. I don't think I'm going to reuse that question mark coil, or inductor, I guess you can say. Straight wire inductor. Then we'll probably get the power wires dropped down on here, and then get my dummy loads down and get this thing tuned, get the input output LC circuits tuned. So anyway, we're coming along, man. We're coming along with it. Davemade 8 to a 12. We'll be back. Alright, brother. We are all done with this 8 to 12 pill conversion. Davemade 8 to 12. This is one of the newer Daves. So went ahead and laid your input network right here. As you can see, there's your output network. The coil was just fine. I just went ahead and shine that copper up for you. I was able to get that tuned out to absolutely a perfect tune, laid out completely well. And I've been shooting this video now for a couple of days, so I can't quite remember everything we've already spoke about, but I tried something a little new on this Dave right here. As you know, on a lot of these cases you'll have these vent holes in the back that are allowing a good bit of the air to seep out the back of the box without actually going through the heatsink on the bottom. So with this one, I decided to try something a little new. And as you see, these are thin copper plates. So I kind of killed two birds with one stone with this one. As you can see, I just kind of bent it like an angle, like an L, you can say. I just bent it down to block the airflow and use this as your ground. So instead of just relying on that bolt on the case, you've now got it compressed against that big copper plate to ground. So I mean, you can't have a ground better than this, big brother. So that worked out perfect, man. Perfect. It completely covered up the holes in the back. So every bit of air going in this box is going to be forced down through the front right here through to the heat sink. It's actually two pieces of heat sink. This right here is pretty much sitting between the heat sinks. Okay, so the air is going to be pushed through all the fins out the back. So I went ahead and did the same for the SO239s. And if you remember, one of the leads were not even soldered to the board on the SOs. And I did clean these SO239s. These are Amphenol SOs. Cleaned them up, shined them up a little bit with some Brasso, and they were good. So I went ahead and put them back on there for you. And so now they are actually compressed. As you can see, they're the copper plate is mounted to the case there, and it's also angled down and soldered to the board. So the SO239s have a real good ground plane against that copper, which is soldered to the board. And this right here is also just to keep it good pressed against the back there. This was enough to hold it bound, just to give a little extra stability. Alright, another thing which I already spoke to you about, I've changed every bit of your hardware over to stainless steel. This is all the hardware that came out of it so far. So your grounding bolt is stainless, as you can see. I'm doing a video. I'm talking about the college basketball games. So anyway, to go on, you wanted the Snake EYE mod. I know I'm kind of going mixed here, but I'm just kind of going whatever pops up in my brain first. And this is something that I did for a buddy of mine, Brad, and you saw the video and liked it. But it's just an idea I had one time. I was like, you know, on those Davemade on the snakes, it'd be kind of cool if you basically created an eyeball on that snake and had it light up every time you keyed up, so the snake's eye will light up. The Snake EYE mod. And again, I think I mentioned it in that video too. It'd be pretty cool, which BBI may have already done this before, I'm not sure, but it just come to my mind when thinking about that. If one of BBI's build, the skeleton he uses has two eyes and they light up when you key. You know, just one of them things, man. It's cool to look at. So we got you 4 real thick 8-gauge wires now instead of 10-gauge wires. Those are all the stuff that all your wires and everything that come out of it. And went ahead and put you some grommets on the back. I plugged up this hole right here. This is for an extra wire. So this is your new concept, real thick 8-gauge wire. And of course, this right here is the 4-pill section that I dropped in here right here. This one right here. That's the one that I dropped in. Another thing you was wanting me to do was the B+ mod. So instead of doing it like I normally do, which on my B+ mods I use 1.5" by 1/2 inch transformers. Since these are 5/8, I went ahead and did it a little different way and used some real thick 12-gauge Teflon. So that's what you got going on right here. This is some thick 12-gauge Teflon. This is a 43 bead, so you have some good high permeability core there to help keep that RF from floating back on your DC line. And let's see here, And I went ahead and made me some extra ones for some future projects. That's what I like to do. If you're in there making something, go ahead and make a few extra. So we got the input of your LC network tuned. You know, you got pretty much 350 ohms there, all paralleling together. We got a 50 ohm coming in, you got to split it to 350 ohm inputs. So that's what's all done through the LC network. I like to call it an LC network because you got your inductor here, and you got your capacitor here. Inductor, capacitor. And I'm going to go ahead and tighten that down so that won't move. It's real tight now, but just to make it safe, I'll button that up before get her packaged up and everything. So let's see. I had to add a new keying circuit in this thing, man. The keying circuit was not working. And I really don't know why. I thought you said it was working. The amp was actually working when you sent it to me, but the keying circuit was not working, so I had to go ahead and put a new one down in there for you. And I went ahead and put your SSB delay switch that you asked for. You said you probably won't be using it much, but if you ever do, that's what that is right there on the back for you. If any of y'all ever known why on the back here these letters are upside down, it's because if you got the box facing you and you want to lean over the back and look down, you'll be looking at them like this. You'll see it, even some the 5 pill, 4 pill, 3 pill boxes will have the front upside down too. Now we're going to do the output of it and everything, and then we're going to attack your fan issue. That's why I have not plugged this hole up yet. I've got an idea that I talked to you about. We're going to try out. Let's see here. I don't want to leave nothing out. Let's see if there's anything else down in here. Ooh. Let's see here. And of course, we got them good $5 output loading caps on there, on 150s. Let's see, I can let you know you changed all the hardware to stainless. I'll have to, I'll use stainless also to put on the top of the lid. Let's see, I think that pretty much does it up. I did check the pass-through on it. The pass-through was absolutely flat, so whoever tuned that out did a good job with that. So your pass-through is flat. So this puppy's ready to rock and roll, man. Yes, sir. Now, before we show you the output, I do need to let you know I do not have a real good strong driver on hand to use with this box, which I will have to get me some. I plan on getting, probably maybe just go ahead and build me a little Texas Star 350. I got more than enough parts here to put a few Texas Stars together. I need to put me together a little Texas Star 350 and just mount it somewhere up here so I can just use that with boxes like this. But I'm just going to be using the 1446 2-pill. Same old little box. I don't know, I think I built that maybe 4 or 5 years ago. So I don't have, you know, as much drive to make this thing do absolutely maximum output. And when it comes to the power supply, at the moment, all I have is a 200 amp unregulated supply. As we all know, this box can pull a lot more than 200 amps. But this will be adequate enough to let you see this box is working and working the way it should be doing. So give me a moment here, and I think I've got everything hooked up, but let me just double check and I'll be right back. Alrighty, got everything ready to go here. Alright, let me show you how much we're going to be putting in it from the 1446 2-pill driver. Alright, we got a 2500 watt slug on this meter on peak, and we got the 1000 watt slug on this meter on average. Okay, so this is what we're going to be putting in it. average bird. Go right there about 100 watts. Okay, which is going to be close to a little bit over 200 peak. Go a little bit over 200 peak. Alrighty. Just to let you see the old Snake EYE mod. Turn the power supply on. So that's the old Snake EYE mod. Alright, so this is what we're getting with the bench radio. Okay, we're putting 4 watts RMS, about 18 to 20 peak into the driver. Okay, this is the bench radio. So on a 1,000-watt slug, this yields us a little bit over 800 bird. Right there at about 2,000 watts. Okay, and that's the box dropping to about 14.4, 14.5. Alrighty, so now we'll go ahead and hook up the hot radio, get this thing a little bit more drive. About 800 bird. Alright, give me a second. I've got to hook up the hot radio. Be right back. And by the way, I do got me an antenna switch now, which I will be hooking up here soon. So I can just reach up here and switch in between radios without having to unplug coax. So I'll be right back. Alright, man. We got the hot radio, the Stickman Copper 29. So now we're driving 8 watts RMS into the driver, which is bumping us up to about 150 watts drive. Okay, so we're putting about 50 more bird into it, and we are putting right at about 180 to 200 watts PEP. Or, well, actually we're putting a little bit over 200 PEP, I believe. Alright, so this is what we are rolling with this amount of drive, which is a little bit better. 1,000 watts RMS. That's over $1,000 RMS. And if you want to talk about the peak, I think that is a little bit more than 2,500 watts peak. This thing is rocking, son. Should I hook up the derail radio? I have not hooked the derail radio up since I got it back. I sent it up there to derail, get a little bit of work done to it, maybe a little bit of modifications, a little bit of upgrades. And I have not got to use it yet. Now I am already pushing these supplies down. That was at 13.8, 13.7 volts probably. I need to hook a dang meter up to it. I hooked my digital meter up to it before, and I didn't see it drop below 14.5 with the bench radio. I didn't check it on the hot radio, but we're pretty much getting close to maximum power supply out. So maybe I'll hook up the old derail radio and give it a quick burp. But first I want to see how much it is doing RMS on the 1,200 watt slug. So give me a second, let me switch the slug over. Yeah, let me switch the slug over. You know what? I am a imbecile. I need to get used to having these dual meters. I don't have to swap the slug over. I just had to turn it off the peak. So, and you know what? I needed to change my batteries out in that peak. I left it on the other day for like 2 days straight. I'm gonna put me up a sign up here. Turn the peak kit off when you go to bed, Gatekeeper. Alright, 2,500 watt slug RMS, peak kit is turned off. So we're looking at the top scale. Where you see the 10, that's 1,000. Beautiful. Let's see, what is that? 10 in between that, so it is doing right there at 1,200 bird. Close to 1,250. Yeah, right there about 12 bird. Right there at that hash mark is 1,250. So I say that's pretty dang good, man, hitting it with two 1446s, not having an adequate power supply for it, and only hitting it with about 150 bird, yes, I would say that is satisfactory. So it turned out really good. This is the first time I've actually been able to convert an 8 to a 12, y'all. I would probably have done a lot more if I wouldn't have gotten so backed up, and I could have kept taking in projects. But I'm going to give a shout out to you, Mr. Sidewinder, over in California. Is that where you're at? You're in California, ain't you? Is this you? Yeah. This will show you how old this is. He actually sent this back when 073 was helping me. That'll show you how backed up I have been. Northern Cal. Yep. He sent this to me. See? Hello, Gatekeeper. And well, he said 037. He meant 073. He even wrote that on the, which I'm going to have to take off with some acetone. He even wrote that on the top, the bottom of the top cover, 037. It's 073 there, Sidewinder. And I have not talked to 073 in about a year. So I don't know what's up with him. I'm trying to get in touch with him and check up. I may just need to swing by his house and say hello to him. But anyway, man. The derail. Should I hook up the big monster? Okay, I'm either going to blow my driver or blow my power supply. It ain't going to produce enough output to hurt the 12. I'll take that risk. Be back. Plus, I need a runner anyway. Alrighty, like I said, this is the first time I've been able to hook up the old derail radio. Now, keep in mind, when I'm showing you this, the RF is flowing out of the radio, through the 2-pill driver, out of the 2-pill driver, through this RG400 coax into the 12-pill, out of the 12-pill, up to this bird meter, to this one. So there we have loss. We have dB loss. I have, and the cool thing about it, we only have 1 watt of loss, but that is 1 bird, which is a lot more than you think. But you know, just the way it is. I have this radio on this module up here, and the reason why I got it on this module, so I can turn the voltage down to get it to do exactly 16 watts RMS. The only reason I like that, because my bench radio, which is under this table, is 4 watts. The Stickman Cobra 29 is 8. I also have 2 backups in there, just in case something ever happens to this radio, that are both at 8. Well, let me explain this. This radio actually does about 12 bird, okay? But I've got the voltage turned down to make it do 8. So I want to just double 4, 8, then 16. I guess I could do 4, 8, 12, then 16, but you know, we had to do a big jump for the monster right here. I can't make this do 12 watts. I probably had to turn the voltage down too low, the radio wouldn't operate correctly. Or put some attenuators in it or something, I don't know. But anyway, attenuators on the output of it. So anyway, well, check this out. This is what you call pure RMS power right here. We got the 25 watt slug in, okay? I got the dead key turned down to about 1 watt. It's 25 watt slug, so you're looking at the top. Load. Well, actually it's a little bit less than 15, but if I hook this radio directly to that meter, it would be right there exactly at 16 bird. So we got a little bit less than 1 watt loss through all the cable and through the amplifiers, which is fashion, common sense. So we're going to be putting 15 watts through the driver. I'm just going to burp this now. The power supply is going to be took down below its cycle, its duty cycle that it can handle. And I need to remove this 25 watt slug so I don't burn my bird slugs. I can't do this with one hand. Y'all give me 1 second here. I'll be right back. Alrighty, I want you to know that the derail radio is now making these 21446s do about 220 bird. So it is making these cotton pickers right here work like 22879s. But we're just going to quickly burp this, okay? I have no idea what the outcome's going to be, but anyway, 2500 watt slug. Looking at the top scale, sorry that coax is hanging down right there. Looking at the top scale. Oh, holy crap! Holy sun! That cotton picker did 1700 bird! Goodness! D-Real, you know what you caught picking doing, son. Goodness gracious. That cotton picker's working like a 16 pill. Here's what I can't believe. It's doing that with two 1446s and a power supply dropping below its duty cycle. That is unbelievable. Unbelievable. You hear these stories about, yeah, man, I know, I got a buddy of mine, you know, he can get $2 grand out of a 12 pill. But that hitting it with two 2879s. Now, if I had two 2879s here to hit this thing with, the derail radio, and a 250, 300 amp power supply, this cotton picker would be off the scale. 1700 bird. Son. Oh, alright, I ain't keying it no more, man. That's actually 1750. If you want to do the proper math. 15, 16, 1750, 18, 19, yeah, that's 1750. 1,750 bird. That is amazing. Let's get the fans situated, man, and I'll be back. So we got one more cool part of the video to show. This thing is working. Alright, now I'm running some tests, and it looks like it's going to work absolutely beautiful. Now I have used such variable motor type control circuits, variable voltage circuits, etc. But I have not been able to use them on high flow DC fans yet. Now I've used them on some AC fans, a couple LD MOS boxes I've done with AC fans. These are the most powerful high flow fans I have personally ever dealt with before. This bad boy right here runs on 3.8 amperes on 12 volts. 3.8 amperes, and it's a DC brushless. This is about as close as I've ever had a fan actually levitating off the table here. This is all the way down, by the way. So this is when this would be creating the most heat. And I have had it running like this for about 15 minutes, and the heat sinks on this device have not even changed room temperature. Let's turn this bad boy up. Yeah, it's a little loud. This is gonna work, man. I'm putting 2 of these on your amp, dude. 2 of them. It's kind of funny. So you get full control over this thing. You turn it up and down as low as slow and as fast as you need. And I'll tell you something kind of funny that happened just a bit ago. I don't know how that thing got in here, but I had a big mosquito get up in here, man. They're about to start rolling around here. But I'm in an enclosed area here, but I think it got through over there. But anyway, that mosquito flew straight through that fan. And I looked down after it happened, and that thing was laying about 4 or 5 pieces on my leg. That fan cut that goddamn mosquito up about 3 or 4 pieces. Boy, these fans are powerful. You turn these fans all the way up, your box might dang lift off, man, and shoot out the side of your house. Goodness. I don't see you turning these fans up to max, but you will have full control. See, that's one thing, that's one reason why I haven't used super high flow fans yet, because that's the problem. You put an awesome fan, absolute awesome fan, on somebody's box that's pushing, I mean, just scooching that air out that amp. But now the fan's too loud and they can't even talk. They literally can't talk because their amp may be sitting literally right beside them and they can't talk. They key up and like, hey man, we can't hear you. All we hear is background noise. So, what I thought I would do is basically put twice, if not 3, if not quadruple more air than the box needs worth of fans, and then give the user the ability to adjust the speed as they wish. But you'll have enough fans blowing at the same time that even if they turn the controller all the way down, that the fans are still spinning to the point to where there's still airflow going out the box. So you can't just sit there and have someone just turn the fans off and be running the box with it off and blow something. And there again, I don't plan on putting these controllers on someone's box that doesn't understand. Let's put it this way. If anybody gets a controller like this, I'm going to make sure that they need to understand. Don't turn that controller down, you know, to the point to where you're sitting out there doing some heavy mauling and your box overheats. Just use the controller to get the fan loudness down to an acceptable level, but make sure the fans are spinning as fast as absolutely possible that you can handle it. The more air, the better. Alright, so we're going to get these cotton pickers 3.8 amperes. Goodness gracious. Alright, let's get your top built, and I'm going to mount the controller right there where that was at. So I think I'm going to have to bend up some tabs too just to support it. I don't know if I'm going to just rely on the mount, the bolt, this bolt or not, just for the support. We'll have to wait and see. I could rig up some mounts for the bottom. But anyway, we'll get it installed for you so we can be done with this. I have me an LD MOS box I need to finish after this for my homeboy, Mr. Lawnmower Man. Alright, we'll be back. Alright, man, we got everything mounted there. I just need to put the grills on the fans so nobody gets their fingers cut off here. So I got it mounted right there. I made some extra supports out of some galvanized steel I had laying around. So it's got extra supports right here holding the board right there, plus by the nut, the mounting nut there for the thing. But this is the first time I have ever seen an actual top of an amplifier levitating. Let me show you how much air this thing is pushing. Watch this. Okay. Alright, I was doing this with 2 hands before, but let's see how close. Okay. It looked kind of cool before because I was actually sitting here holding it steady while it was sitting there and levitating. Let me see if I can't try that. Alright, right now it's levitating. The top is not touching. It is levitating. Look at that. I'm going to turn that down. Goodness gracious. Brother, I think you have more than enough air. Just to show when you turn it all the way down like that, one of them may turn off. It's just all about how high your voltage is. Right now I think I got the voltage on about 14 or so volts. But that's all the way down, okay? If you see, I'll just start easing it up. See, that's just turned up just a quarter of a way, and I'd say that right there is adequate air. And there are loads of air coming out here right now. You hear it rattling because I ain't got it mounted, got the top mounted yet. But anyway, another thing I went ahead and did, let me turn the power off there just in case that thing turns on and chops my dang fingers off. What I went ahead and did just to be on the safe side is I added a relay in here for the fans. That's what you see right here. It's kind of hard to get in the view. There we go. I added that relay right there for the fans just to help take the load off this switch up here. It probably would have been fine just to hook these fans directly up to the switch, but we are talking about what is it? Around 7 or so amperes, possibly, if you had the fans turned up all the way. So yeah, so just, and plus we've got a lot of stuff soldered to this switch up here already. So just to be on the safe side, that switch up there along with the remote in the back. And see, that's another thing I was wanting to think about too. If I had this right, if I had these fans soldered straight from the switch, being powered from the switch, and if someone hooked up a wired remote or a Y-mode, a wireless remote, but a wired remote, that means that you would have all that amperage for them fans traveling down the wire to the remote and back from the remote down. But since I have now added this relay in here, the remote or the switch up front right here is the only thing it's doing is giving this relay's coil a positive voltage to latch it and then allow the power to lead from the relay over to the voltage regulator, from the regulator to the fans. I am finally done. This was a little bit of a longer project than I anticipated, but they all seem to turn out that way. So I need to secure that tube right there before I mount the top on here, and I need to put 2 fan grills on the top. And then I will probably come back one more time just to let you see it all put together and the fans scooching along there. Alright, we'll be back. Alright, brother, she is all done. I would like to do a celebration sig, but the problem is I'm now enclosed in an enclosed area. I don't need to be doing no celebration sigs. Back when I was in the open area I could do stuff like that, but man, I tell you what, this is the box, this takes the record right now of the box with the most CFM, with fans pushing the most CFM through the back of the box. I mean, these things are scooching along, son. Whew. If you can handle the, if you're running this in a mobile or something, you can handle the sound, man, and lead these things all the way up, man, shoot. This thing will never get hot. Coming out there is wouldn't be turn, brother. Davemade 8 pill converted over to a 12. Two super fast fans to make up for the lack of airflow for the fans that were on it. That's all the wiring, a couple components that came out of it. And this is all the hardware that came out of it. Okay. All this was, none of this was stainless steel. Okay. All this is stainless steel. Even the screws holding the fan to the case and holding the grills are stainless steel. So all the hardware is stainless. Now the fan grills are chrome plated, but all the actual hardware itself are stainless. So this thing is stainlessed out, man. Anybody out there got a Davemade like this you want something done to, upgrade something like this, give me a shout. Like my boy Stickman used to say, we'll help you out. The old Gatekeeper out here around the northeast end of Georgia. Another Davemade made 10-8 straight and we're gone. Bye-bye.